Dun, 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 dun. I really should get a theme tune for this intro. So why am I starting today's video like a movie? Well, this video is going to be kind of like a movie. It's certainly going to be as long as a movie. I hope I don't get copyrighted for that wonderful rendition that I did just then. So when I first got into YouTube and multi-rotors, I decided to build a cheap quadcopter and document it, and I called that video Build a Cheap Quadcopter. And back then, I think it was at the start of 2015, mini quads weren't that popular and multi-rotors were just sort of getting started, and people were building 450 size quadcopters such as the one that I built. However, the hobby has moved on, and now when you say quadcopter, the mini quad is more synonymous with that title than say a 450 quadcopter. So I thought it's about time that I did an updated version of that video, but with a mini quad. So this isn't going to be any cheap quadcopter though, because about 3 or 4 months ago I did 2 builds on the channel. I built a ZMR 250 and I built a alien frame build, which cost about $1,000. In fact, both of them were quite expensive builds. But now you don't need to go expensive to get that kind of performance. So that is what I am going to build today. It is a cheap quadcopter, but with the performance of a expensive one. So just like before, I am going to do a component shop online, and then I'm going to build it, I'm going to tune it, and I'm going to fly it. And I'm going to take you along with me, and here is the finished product, and it has come out so well, so I'm so excited for you guys to see it. What I'll do, as well as the shop, is I'll put a link in the description to all of the parts, and I'll also explain the mistakes that I made along the way. So, without further ado, let's get onto it. So starting off with the shop, I'm going to be getting all of the components from the same shop, which is Banggood.com, to keep it consistent. And also, I just really like buying stuff from Banggood. They are really cheap and the customer service is great. Now, before I start going through the components, I can already see the comments in my head where people are saying there is a cheaper frame than that, there is a better motor, there's an upgraded ESC since then. And one thing I'm going to point out is that when I buy these components, it usually takes about 3 weeks for them to turn up, maybe even longer if they are on back order. It then takes me probably 2 weeks to make the video and upload it, so we're talking about maybe a month and a half between the time that I bought it and the video comes out. So yes, they may be a better motor ESC, but at the time, these were the best components, unless I missed something. However, this quadcopter has already been built and it flies really well, so let's take you through the components. Now, again, before I do that, what I'm going to do is tally up the cost in the below as we go along, because I know that is important to people, and this is meant to be a cheap build, so I will put the price in pounds and the price in dollars. I'm also going to split the video up into 3 sections, so there's going to be essential items for the quadcopter, and then upgraded items, and then just tools and stuff like that that you may already have. So I'm going to start off with the frame, and it's going to be the Martian 2 frame. So the Martian 2 frame is a clone of the Alien frame. Did you get it? Martian, Alien. Now, the Alien frame was made popular last year by the Rotor Riot guys, and it won quite a lot of competitions. I think frames have moved on to be even smaller now, but I do really like this frame. It's really good quality, and it's very cheap at just £21.35. The Impulse RC Alien frame was about $150 or something like that. It was really expensive for a frame, so obviously I'm going to knock that down and maybe even get better performance than the Alien. We will have to see. So this is the frame that I'm choosing. Next, we are onto the motors. These are the Racer Star 2205 2600 kV motors. Now, I did some thrust tests on the 2205 2300 kV motors when they came out back in August, and I was really impressed with them. And I think a lot of people are going to be asking the question, should I go for the 2300 kV motors or the 2600 kV motors? And What I will say to you is, if you go for the 300 kV motors, then you can have cheaper ESCs, because the 2600 kV motors are going to rev higher and they're going to draw more amps. So I would go with the 2300 kV motors if you're planning to race and want to use 20 amp ESCs. However, I think the 2600 kV motors are going to be better for freestyle, but you will need higher amp ESCs. So the next component is, of course, the ESCs. I'm going to be using the 30 amp Racer Star ESCs. I did a thrust test of the 20 amps and they performed really well. Again, if you are using the 2300 kV motors, then go for the 20 amps. They are cheaper. I think those are about £33 and these are £40. And these are the V2s that have the solder pads, so you can solder the motors direct to them, which I like. Next, I'm moving on to the flight controller. Now, when I originally got all of the listings up for components of this quadcopter, this is the flight controller that I bought. However, it seems that they have discontinued it or it's out of stock, which is a shame because it's a really good flight controller and it's the cheapest. It's £14.39. However, they have released a clone of this. I mean, that SP Racing F3 board was a clone anyway, but this is another version of it. This is a Naze 32 F3 flight controller, but it is the same board layout as the SP Racing F3, and it's a little bit more expensive at £17, which is a shame, but it's identical. I think the only difference is the buzzer, which I'm not going to be using anyway, has got a connector on it rather than a solder pad, and I believe the buzzer is connected up wrongly on these boards anyways, but if you use the solder pad underneath, then it will work. So I have used this flight controller and I really like it. I used it on the Mini Owl build and it's really easy to set up. However, the flight controller does not have a built-in regulator, and because I'm using that Martian frame which has a power distribution board, it takes the power direct from the battery, so we're going to need a regulator for the flight controller. I'm going to be using this one here. It's really cheap as well, and I also use it on the Mini Owl build and it works really well. Next is the VTX, so I'm going to be using this Eachine VTX. It's the cheapest one out there at just £10. It's 40 channel and 200 milliwatts. You aren't going to need any more than that. It doesn't have a 5 volt out to the camera, but we're not going to need that because the camera that I'm going to use has its own built-in regulator. To make it easy for yourself, I will get the SMA female version rather than the RP-SMA. It's more compatible with other components. So the camera, now this is the only premium part that I am using in this build, but I strongly recommend that you get it. Why? Well, the HS1177 camera is known for being the best FPV camera, and they have released this one, which is the HS1190 Arrow V2, and it's exactly the same camera, except it's got a brilliant built-in OSD that is completely configurable. Now make sure you get the V2 version because the V1 version was rubbish and is a completely different camera altogether. But this camera is brilliant. I am getting the IR block version and I'm getting it in orange because why not, and the NTSC version as well. So next is the control system. I'm using the FlySky FSI6 transmitter. Now I use the PWM version for this build and I didn't realize there was a PPM version. If I did, I would have got that one. It's a little bit more expensive though, just a couple of pounds more. But this build video will be with the PWM version, and I guess people may already have this version. I think the PPM version is probably newer. However, it's a bit of a hassle getting all the individual channels from the flight controller, but I'll show you how to do that anyway. But my recommendation would be to get the PPM version. Next, we have the FPV goggles. Now, I'll be using the Eachine VR008 because that is the version that I have. However, I think I would recommend to a new flyer to get the 007. Why? Well, the 008, first of all, it looks like it's got diversity, but it hasn't. And it doesn't come with a battery. and there's no 4x3 screen output, whereas on the 007 it seems like you get a battery and you don't need the diversity anyways, and you can have 4x3 output as well as 16:9. So personally, I go for that. They are exactly the same price. Next is the props. I'm using the King Kong 5043 leaf props. Again, I'm sure since this video was started, there are better props out there. However, these seem to be a clone of the HQ Rotogeeks props, and they look pretty nice, and they're very cheap, so I'm getting these in green. Next is the battery. There can only be one battery, in my opinion, and that is the Dynegy 1300 4-cell battery. They're just really good. I did some tests on these in the past, and I'm really impressed with them, and they are pretty cheap as well. Now, this is an essential item in my opinion. These are battery straps, and Banggood sell the cheapest battery straps. You are going to be an advert for Banggood, I'm afraid, and there are other battery straps out there, but I really like these because they have got this material on here that stops the battery from sliding, and they're really cheap. I'm going to be using my Rotogeeks battery straps that came with the HQ props, but they're essentially the same as these, and you get 5 of them for £1, so why not? Now, this is the section of the upgrades that you can get for the quadcopter. In my opinion, these are the best antennas for the price. These are the Omway cloverleaf antennas. You're going to get better video signal from them. I'm getting the SMA version because it's compatible with immersion. However, if you have the VR007, which I think uses the RPSMA, then you're going to want to get those, otherwise you won't have the correct mating on the antenna. Now, again, this is optional, but this is my favorite action cam for a quadcopter. This is the Foxeer Legend 1. It's really cheap. It's got the best sound and the best picture quality out of all of these slim line HD cameras, in my opinion, and that is the one that I use. Of course, you're going to need a micro SD card for that, and this is the cheapest Class 10 micro SD card on Banggood at about £5. Next, you're going to need some cable ties, and this is the section where you may already have these items, but these are the particular ones that I use. They are really nice. They are slimline, and they are 100 millimeters in length, so they are perfect for tying up your VTX. I also use longer cable ties or zip ties as well. These are used to tie up your ESCs. Now, again, you may already have this. Heat shrink, for me, is essential, again, though you probably already have some, but this is what I use. You're going to need this to mate the VTX and the camera together and have a nice, neat job there. Of course, you're going to need a soldering iron. Now, I use a expensive $200 soldering iron, but it really isn't needed. This is just my opinion, but people say, get yourself a good soldering iron. But really, a cheap one's going to do the job. So you can get a cheap one like this. This one's actually really good. You can adjust the temperature, and it's just £9. So, yeah, you can use that one. No problem. Just my opinion. And this is the solder that I use as well. Make sure you get 60-40. I use the 1mm thick leaded solder. This is the exact one I use, and it works really nice. Now, if you are having problems heating that solder up, get yourself a flux pen. It will let the solder flow much easier to the solder pads. However, I'm using an iron that gets really hot, so I won't be using one in this build. Next is a tool set. These are hex drivers for an RC model. They are really handy for the screws for the frame and also the motors. I can recommend them. However, Allen keys will be just fine also. You're going to want some pliers and some cutters for cutting down the wires and holding stuff in place. While you solder, I just use a pair of pliers and a rubber band, and that does the job for me. Now, you won't go far wrong using a hex screwdriver. These are good for holding the nuts while you are screwing the frame together, and they're also good for the props as well. Again, you may have those already. Now, this is a battery strap to hold the HD camera in. I get these from Banggood. They're really cheap, and you get 50 of them. Next, you're going to need some NiCad batteries. I recommend rechargeable ones for your transmitter. And lastly, again, I probably don't need to tell you where to buy or get a USB cable from, but you're going to need one to connect the quadcopter to the computer to tune it. So here are a couple of extra sundries that you might be interested in. This is the charger that I use. It's the IMAX B6 AC V2 charger, and I'm not including this in the price of the build because a charger like this is for charging all your gear, not just this one specific quadcopter, and this is the one that I use if you are interested. The next one is a sort of nice to have product, and this is a 90-degree SMA adapter. I'm going to be using this so that I can sit my VTX flat against the quadcopter's top frame and then angle my antenna outwards. But this VTX that I'm using in this build is so small you can actually mount it vertically and then just use the antenna SMA connector to keep it in place. However, I'm going to be using one of these as it's going to look nicer. Now this next product, again, it's another nice to have product, and it's the only product that you cannot get from Banggood. This is the Pololu 12 volt step up step down voltage regulator. Now again, this is a nice to have item because the VTX that I'm going to be using and the camera all going off the power distribution board, I imagine that it's going to get some noise coming through, and I'm a bit OCD when it comes to noise on the video. So if that does bother you, then definitely get one of these step up, step down regulators, and then you can connect your camera to it and also your VTX. I am going to do the build without this, and then I'm going to add it later to show you the difference. The next one, again, it's a nice to have item. This is spare XT60 connectors because I really don't like the XT60 connector that comes with the Martian frame, so I have bought some separate ones. And lastly, for any rework that you need to do, I use one of these. It is a vacuum solder sucker, and you can heat up the solder if you have made a mistake and then suck it out and then remove the component. So that's about everything. Let's get on to the build. So I'm starting off with the power distribution board. The first thing to do is tin all the solder pads. I am going to be using every single pad here, so I'm going to speed that up so you don't have to watch it in slow motion. Next, I'm taking the XT60 connector and matching up the plus and minus. So there is a plus and minus labeled on the XT60, and it's also labeled on the power distribution board as well, so just match that up. I'm now tagging these into place, and then once that is done, I am filling both cups up with solder, making sure that everything is covered. And that is the PDB soldered up. Now I'm taking the longer screws in the package, and those are going to go through the frame, and I'm going to use the pancake method here of being really quick so that you don't have to hold down the screws with any tape, and then I am fitting the arms on. Now you're only given two types of different screws with this, which is quite nice. You've got long screws and shorter screws, so all of these are going to be the longer screws. So now I am taking the arms and just lining them all up. I haven't filed down any of the carbon. I don't really find a need for doing that. So all those are in place. The next thing to do is to put this PDB cover over the top. This is to stop the power distribution board touching the carbon underneath so that it doesn't short. That just fits over the top nicely like so. And then on goes the power distribution board, so it doesn't really matter which way up it goes because the USB connector on the flight controller I'm using comes out the back. So I'm just making sure that that is all fitting flush. Now I'm putting the other screws in, so these screws actually face down, unlike the original alien frame, and I'm screwing them in because they are really tight, so you can't push them through, but if you screw them in, they go down nicely. So I'm now screwing in the provided standoffs for the flight controller to slot into. You can just hand tighten those on because we have nylon nuts going into metal screws. So I have put all of the nuts on the bottom and I'm just tightening them up. There's no need to use a hex wrench on the other side because they are tensioned nicely. And now I'm putting the motors in. So I'm just hand tightening the screws. I'm putting all of these screws in, and I'm not using Loctite because I found that you don't need them on a mini quad. I've not had one come loose yet if you tighten them up properly. So make sure that the wire is pointing down the arm, and that was the clockwise motor, and this is the counterclockwise motor. I'll just show you a couple of these and then sort of spin it on because it's not difficult putting motors in. So I'm tightening all that up now. That's all of the motors in. And then flip it around here, and you can see that the motors have directions on them. So that's clockwise, counterclockwise, clockwise, and counterclockwise. Now I am cutting one of the ESCs to length to solder to the power distribution board, just holding it up against the arm, and then I'm cutting the motor wires shorter. Now I'm cutting some of the heat shrink away because I'm going to desolder the ground cable as it's not needed. I'm then going to strip the wires of the ESCs so that they can be tinned up. I am also stripping the motor wires. This is a tool that I've got, I really like it, but it's not necessary. You can just strip them with the cutters. I do really like this tool though, but it's expensive. Saves you time though. So now I'm going to remove the ground cable and unravel it and then cut this wire up because I'm going to solder that straight to the flight controller. And now I am tinning up the positive voltage and the negative, and also the solder pads for the motors to connect. And then I am soldering in the positive and negative wire of the ESC, and also tinning up the motor wires. I am then soldering the motors direct. We don't need to worry about the direction of the motors. I'm going to change that later in BlHeli Suite. So those are all soldered straight for a nice, neat job. So onto the next ESC, I have measured it up and I'm stripping the connectors there. And I'm cutting away the heat shrink to desolder that ground cable. And I'm just cutting that short. Now tinning up the pads and tinning up the power. And then soldering that into the PDB. Cutting the motors short and stripping those wires. Tinning those wires. And then soldering them direct to the ESC. Same with the next one, cutting it to length, stripping the wires, cutting away the heat shrink, desoldering the ground, unraveling that cable and cutting it short, then tinning up the connectors there, and soldering up the pads, and in goes the positive and the negative wire of the ESC, cutting the motor wire short, stripping those and tinning them, and then soldering them direct to the ESC. The last one, I'm measuring up again, cutting away the heat shrink to desolder the ground, and unraveling that and cutting the cable, and then stripping the wires and tinning those up, and tinning up the pads on the ESC, soldering the positive and negative to the power distribution board, cutting the motor wires to length and stripping those wires, tinning those wires and soldering them straight to the ESCs. And there we go. So next I'm just fitting the flight controller over the top. And now I am taking the wire for motor 1 and cutting it to length, and this is going to solder direct to the PWM ports. So I'm stripping that wire now, and I've decided to tin all of the PWM solder pads up at the same time. And again, just tinning that wire up and soldering in motor 1. Then I am just moving the wires around. This is for motor 2, cutting it to length so we've got a nice neat job. Stripping that wire again, tinning up that wire, and then soldering it in to PWM2 or motor 2. So this is motor 3. Again, I am just directing the wire underneath and then cutting it to length. Then I am stripping that wire, tinning it up, and soldering it to motor 3 on the flight controller. Lastly, this is motor 4. Again, just putting the wire neatly underneath the flight controller and cutting it to length, and then stripping the wire, tinning it up, and then soldering it to the flight controller. Next, I'm putting the 2 pins provided in the kit to power up the flight controller. So I've put the pins in, and then I'm reversing it so that I can solder the pins in underneath. This is to house the 5-volt regulator that's going to power up the flight controller. It's bridged there, so I'm just dabbing it with the iron there and just securing the flight controller back onto the standoffs. And then this is the regulator that just fits over the top there quite neatly. And then I'm going to solder those in. So that's both sides soldered in. I'm just going to clip the excess pins off there so that it's neat. Next, I'm taking the power connector that comes with that regulator and cutting it short, and then stripping the ends off and splitting the wires. Making sure that all of the wires are stripped. And then I'm going to tin this wire up for the positive and negative, both sides. This is then going to solder onto the PDB and then onto that regulator. So it's going to be one of the spare pads that we've got. So in goes the positive. I'm just soldering into the side of one of the pads because I'm going to use the other side for something else. Just remove the flight controller so that I can get to the pads easier. And in goes the negative wire. So I'm then going to put the flight controller back on there, and then I'm tinning up these solder pads on the regulator. So this is the positive voltage going in. And then this is the negative going in. So now I'm going to plug in one of the connectors to the receiver. So you're going to need both of these for PWM. So it's in one side and in the other. Now you'll see why it's better to have ppm. So I'm removing 2 of the pins from this side of the connector. That is because we only need power from the throttle. So that's the power cable there from this particular cable. And then first goes in the aileron, and then the elevator, so 1 and 2. And then this is auxiliary for channel 5 and auxiliary for channel 6. And then the other cables, we can just take a screwdriver and lift up the pads there and remove them because they're not needed. So we're only taking the aileron, elevator, and channel 5 and 6 from this side. I wish they were all on the same side, but they're not. So just lifting the pins up and removing those excess wires. And then I'm plugging that back into the flight controller. So on the other side, we are taking the throttle. So the throttle goes into channel 3. So it goes AETR, aileron, elevator, throttle, rudder. So that's the throttle going in, and it's taking the power from there as well. And then, of course, this is the rudder. So just throttle and rudder from the other side. Everything else is not in use. So I'm going to disconnect that connector too and remove all of the other wires that aren't in use. You can leave them there, but you're just going to have a mess of wires dangling about, so I like to keep it neat and just remove them. So that's all of those wires coming out there. And the last one. And then that can plug back in to the flight controller. Next, I am unscrewing the screws on the back of the camera, and that's because I'm going to use the other case that is provided because it's going to fit into this frame better. So 2 screws out of the back there, and then the back will come off and the circuit board will fall out. So the circuit board comes out, and then you need to unscrew the lens, and I'm going to put it into the other case. That's because the holes are in a different place, so you've just got a single hole on the side here for pivoting the camera. So make sure that you put the circuit board back in the right way around. Also make sure you don't get any dust or any marks on the sensor, otherwise you'll get that on your FPV feed. So I'm screwing the lens back in. I haven't touched the stopper there, so it should still be in focus. However, you might need to refocus the camera doing this, but it's not a big deal. So I'm screwing that back in. Next, I'm taking the camera plates and also the screws provided in the Foxeer camera, and that is just going to screw into the side of these plates here. Very similar to the Alien frame, however there's less components. And I'm not using the back plate that's included in this, it's just no need. So now I'm taking the wiring loom and I'm going to cut it shorter. I'm then going to strip the video cable. So the video is the yellow wire, and the bluey purple wire is the VBAT sensor that's going to go to the power distribution board. The red wire is the power to the camera, so the camera can take a 4-cell voltage, which is nice. I'm just stripping those wires. The green is the audio. I'm going to connect that up because why not? There's a microphone on board this as well, which is different to the original HS1177. And this is the ground cable to the power distribution board. So now I'm going to tin up those wires. This is the audio cable. And this is the audio cable on the VTX. This is the video cable on the VTX. They're not silicon wires, unfortunately. So I'm just putting some heat shrink over the top of there. So that's the video and the audio, and these two are going to get soldered together. So that's the video and the audio. And I'm just going to tin up the rest of the wires while I'm here. So that's the positive, that's the VBAT, and that's the ground. And again, positive and ground. We've got a spare ground cable there, which we'll remove in a bit. But now I'm putting over the heat shrink and using a candle lighter to shrink it. Don't leave the flame on too long, otherwise you'll burn the cables. So I'm just doing quick flashes of it there. Same with this one. The rest of the cables are going to connect to the power distribution board. So I'm just going to remove the cable from the VTX here because we've got a spare ground cable that we don't need. So I'm just going to remove that and press everything back down and push it back into the VTX. Now I'm going to remove the flight controller just so that I can get access to those solder pads there. And this is the positive cable going in from the camera. See, I'm using the other side of the solder pad. And the same here, so that we don't disturb the one that's already soldered. Could do with an extra pad really for this, but never mind. And again, this is the VBAT sensor for the camera going in for the on-screen display, and I found a spare slot in the middle there. Just making sure I don't disturb the wires already soldered. And then I flip the quadcopter around, and then this is the power for the VTX at the back of the quadcopter, so positive and negative going in. And that's going to power up the VTX. So I'm just going to neaten all the cables up, force them underneath the flight controller where I can. So that's for the receiver. And just place that down, move the wires out of the way. And now I'm installing the standoffs. And these are the smaller screws that are provided in the kit. I'm just going to speed that up so you don't have to watch it in slow motion. And then I am screwing on the nuts. These are the nylon nuts for the standoffs. And you can really hurt your fingers doing that manually. So in go the rest of the standoffs. And then I'm using a couple of cable ties to hold in the receiver so that it doesn't move while we're flying. So I'm going to cut that short and then put another one in just so it's properly secure. And I'm going to cut that short too. I'm also using a cable tie to neaten up the cables of the receiver because we've got a lot of them. And I'm going to cut that short too. So this is the top plate for the antenna housing. You're given these sort of collets. They do have a thread, so you have to thread them on, unlike the original alien frame. So these are the longer screws that you have. So you need to screw these on, not all the way to the end, because you still need to screw these into the standoffs. And there's no press nut here, just like the alien. So you also have to screw this on. Now I have reversed the screw on this one so that the nut doesn't get in the way of the VTX. And that's going to press onto here like so. Then I'm going to take the nut and just tighten it up. And then I'm using one of these 90-degree antenna adapters, and that's just going to fit through the hole there like that. And you can see the bolt doesn't get in the way. So I'm taking some really thin cable ties here and just tying the VTX down best I can. And just a second one to make sure it's extra secure. You can just about access the channels there as well on the VTX, the dip switches underneath. Make sure that you cut a hole in the heat shrink so you can access them. Next, I am pressing the camera module into place. Now it takes a little bit of time this, but it does slot in eventually. make sure that it is slotted in perfect, otherwise you will snap the housing when you put the lid on. And I'm just going to tighten up that nut on the top there, just still about reach the bolt underneath with the hex driver. And now I'm plugging in the VTX, making sure the pin's the right way around. That should slot in. And then slotting in the camera module. Again, it's a bit tricky, but it fits just about. And then I'm using a hex driver to screw in these screws into the standoff. So these go into the standoffs at the back. You see they move freely because I didn't tighten up those collets to the end. And here is the rest of the short screws going in. So I am just feeding the receiver antennas through to the top there, and I'm going to use some cable ties to secure these. It's a bit unorthodox, but it works. So I'm going to use the stiffness of the cable tie and also tying it up in a way so that the cable ties sort of point up. And the idea is that if the quadcopter lands upside down, the cable ties should fall forward and not into the props. So they're at a slight angle, so they miss the props. Then I'm using some other cable ties to tie the antennas up. Now you can get one of those antenna kits. That's probably better, but that would have upped the budget slightly, and I don't have any spare ones, so I'm using this method. So I'm cutting off the excess of the cable ties there, and I have also added some more cable ties to the end, and you can see there that it sits in a nice V formation. Lastly, I'm installing the ion weight antenna, and that's going to screw into the VTX. You want to make sure that you have that on before you power the quadcopter up, or you risk blowing your VTX. And lastly, I am cable tying the ESCs in, and we are complete. So now it's time to set up the transmitter in preparation for plugging the quadcopter into the computer and flashing Betaflight to it. Now, one thing that I really like about the FlySky system is it's really easy to set up and there's not many things to change at all. So if you took this transmitter fresh out of the box, then it will already be bound to the receiver that it came with. However, if you are repurposing this transmitter, you will need to set up a new model and bind it to your receiver. So to do that, you need to turn the transmitter on, and you need to change the model because this is going to be the model that it was selected with whichever aircraft it came with. So to change the model, you long press the OK button and go into System and then Model Select, and then use the up and down keys here to change the model. Now to save that, you have to long press the cancel button, which seems counterintuitive to me, but it's how the FlySky system works. But seeing as this is fresh out of the box, I'm going to keep mine on Model 1 because it's already bound. So, whichever package you received this transmitter in, you should have been given one of these, hopefully. I mean, don't worry if you haven't been given one of these, because it's literally just a servo connector with the signal and ground shorted like that. So this is to be plugged into your receiver on what looks like channel 7, however it's only a 6-channel receiver. So I think it's labeled the B/VCC channel, which is the bind channel, and you just pop that onto the receiver and then power up the receiver. You should get a fast flashing light. You then hold down the bind button on the transmitter and turn the transmitter on, and the light should flash really quickly. You'll probably get a beep on the transmitter to say that it is bound. And then when you turn the transmitter off and switch everything back on, it should beep and you'll get a solid light and the receiver is bound to the transmitter. So if it's already bound, there's just a couple of settings that you need to change on the transmitter, and it is optional, but it's just how I like to set it up. So if we long press the OK button and go into System, we're going to want to set up the failsafe. So go down to RX Setup and then Failsafe. Now you can see here that channel 3 and channel 5 is already set to -100. So just go back into there and scroll down to channel 3, because channel 3 is the throttle. So if we go into there, it says failsafe is on, and then what this is a bar of where you want the failsafe to kick in. So obviously for the throttle, we want it to cut the throttle, so it's going to be at the bottom there. And so once you are in your position that you want it to be, which is idle down, then you long press the cancel and that will save. So we also want to do the same for the arming switch, which I will set up in a bit. So we go into there and same again, you want it to disarm when the failsafe kicks in. So that is the failsafe. And then if we go back to this menu here and go into the setup, we're going to want to set up the auxiliary channels, because this is a 6-channel transmitter, but you can see that we've got 10 options in total. Now there is a bit of firmware that you can install that enables all 10 channels. We don't need that for this build. We just need a arming switch and a mode switch, okay? But usually out of the box, one of these dials is set up as one of the channels and maybe one of the others. You can have any 2 combinations. So I need to set up this switch for arming, which is switch D, and this switch for our modes, which is switch C. So to do that, we need to go into the aux channels option here, and the way that you move between the two, so that's channel 5, that's channel 6, is press the OK button, and that moves between the two, and then use the up and down buttons to get to the switch that you want. So I've got channel 5 on switch D, which is for arming, and channel 6 for switch C, which is the 3-position switch for our flight modes. And then of course you need to long press cancel to save those changes, and that is everything. So here we are in the Betaflight configurator. Betaflight is the only way to get this quadcopter flying how I like it, in my opinion. So the board comes with clean flight flash to it as standard, so I have got the board connected via the USB connector into the computer, and you can see there it is showing as COM3. So I need to go into the firmware flasher here and select the board. So it is the SP Racing F3, which is there. And then I'm going to select version 3. We need the manual baud rate at 256. And I'm going to do a full chip erase. So I'm going to, first of all, select load firmware and line. And then scroll down here where it says that it is loaded online. So then I'm going to select flash firmware. And that is flashing no problem. So a few people have been having issues with the drivers for Betaflight, so I will link a tutorial in the description of this video to show you how to combat that, because there's various different driver conflictions and stuff like that. So it says programming successful there. So now I should be able to connect to the board. And there we go. So the first thing that I'm going to do is calibrate the accelerometer, making sure that the quadcopter is on a level surface, which it is. So calibrate accelerometer, and you will see this change slightly until it is level. And that has completed. So next I'm going to go into port, and you can see there that nothing is selected at the moment, but that is fine because I'm using the PWM for this one. However, if you were using PPM, you would need to select serial RX. So next on the configuration tab, we have Quad X. And up here we have one shot 125 selected, which is fine. I'm going to keep motor stop switched off so that the motor spin when the quadcopter is armed. The minimum throttle is probably about right at 1070. I'm happy to see that they have corrected this for the stock settings of Betaflight, and the maximum throttle is set at 2000, which is also correct. So in the receiver mode, it is set to RX PPM, which would be correct if you were using a PPM receiver. However, I'm not. I'm using PWM, so I'm going to have to select this one, which is RX Parallel PWM. Now, I don't need to select any of the battery voltage settings, even though they are selected because the FPV camera has that built-in OSD where it gets the voltage from the battery. And I think that is pretty much it there. So if I save and reboot, we should be able to go into the next tab. So that is Pid Tuning. So I'm just looking at these stock PIDs here, and I'm going to put some PIDs in that I know work well with a quadcopter that's very similar to this. So this is just going to be a reference point. So for the roll, I'm going to boost that up to about 60. The integral, I'm going to just boost that one up to 45. And the derivative, that is going to go all the way up to 60 as well. I actually might boost the roll and pitch up to 0.8. If it's too much, I'll reduce it later. So the RC rate I'm keeping at 1, but the super rate I'm going to change to 0.8. And the same for all of these. So just how I like to have it set up. And the RC Expo I'm going to keep at 0. Everything else I'm going to keep the same, so I'm going to save that. Now I'm going to go onto the receiver tab, and at present we won't get any values here because you actually have to plug in the quadcopter to a battery for the receiver to start. So I'm going to do that. I'm just going to plug in a 4-cell battery here, and then I'm going to turn on the FlySky transmitter, and all of a sudden we are getting some values here. So I've got throttle, and the minimum value there is 997, and the maximum is 1800. I got my trims in the right place. Okay, the trims aren't center for this, so I'm going to change that. So there we go, 997 and 1935. Just checking out the roll, the pitch, and the yaw. And then my auxiliary, so I've got my 2-position switch on auxiliary 1, and that's going to be for arming, and then the 3-position for the flight modes. So the channel map for FlySky is AETR, and then 1, 2, 3, 4. You can see there that the quad in the preview is actually drifting slightly. So you can actually correct that with the trims. So we've got some slight yaw and some slight pitch and slight aileron as well. So I'm just going to see how that is now. It is not moving, so we are all good there. I'm just going to save that tab. However, I don't think I changed anything. Onto modes. So I'm going to have my arming on a switch. So I'm going to add the range there, and that is going to be on my auxiliary 1. So I'm just going to move the sliders down here in range. There we go. I'm not going to use air mode. I've been having better success without air mode. I'm going to add my 3 flight mode. So angle, that's going to be on the auxiliary 2. So angle is going to be my first mode. And next horizon. And then acro. So I'm going to save that. I'm also going to enable expert mode to see what is set up on the failsafe. So stage 2 is enabled, and it's got it as drop, which is fine. I'm just going to disable that. And we're just going to have this value here as the failsafe. So we can check that in a bit. I'm going to save and reboot that. So next we want to calibrate the ESC, so I'm going to go onto the Motors tab here, and the way that you do this is you disconnect the battery at this point, and then you have to tick this little disclaimer here to say that you have removed the props, so that is important. Do not do this with the props on. And I'm going to increase the master to full, and then plug in the battery. And after you get the tones, you can drop the master, and the ESCs reboot, and you should be able to lift the throttle and all the motors are going. However, because I soldered them all straight, all of the motors are spinning clockwise, so I need to change that in BlHeli in a bit. What I'm going to do is just lift the throttle and see where they're idling at. So they're going to want to idle at about 1040. So I'm just going to stop that and go back into configuration. And we can change that to 1040. And save and reboot. And then what I'm going to do is go into the receiver tab and see where maximum throttle is. So it's at 1934. A little bit higher if you force the stick up, 1939. So let's change it to 1934. So if we now go into configuration and go on the maximum throttle, we want 1934. And that is the maximum throttle set. So the next thing that I'm going to do is go into BlHeli Suite and reverse the direction of two of the motors because they're all running clockwise at the moment. Now before I do that, you're going to want to disconnect from Betaflight, otherwise you won't be able to connect to BlHeli. So this is BlHeli Suite, and I'll put a link in the description of where to get this, and I'm just going to use this for the motor direction. Obviously there's a lot of settings in here that you can change, however it's not really needed for this build. So I'm going to go to the port at the bottom there and change it to COM3 and then select connect. And then the next thing I'm going to do is press the check button, and that's going to make sure that we have all of our ESCs connected. You can see there that they are, so I'm going to press OK. So this is where I find BlHeli a bit of a pain because I only need to reverse the direction of two of the motors. However, all four are selected from stock. So to unselect them, you just tick them here. And the motors that I need to reverse are motors 2 and motors 3. So I'm going to first of all select this one, and then on motor direction select reversed, and then I'm going to click right setup, and it says ESC2 right, OK. And then I'm going to unselect 2 and select 3, and I'm going to reverse that one too, and then do right setup, and it says right, OK. Now if you do the check button, it will say that ESCs 2 and 3 are reversed, and that has been successful. So now all of our motors should run in the correct direction. So I have added a couple of extra components to the quadcopter since the build, so I will just talk you through that. You can see first of all we have the optional Foxy Legend 1 camera up the front. Now the Legend 1 comes with these Velcro sticky pads, and I have stuck them at the front here of the frame, and that is so that the camera can have a little bit of an angle on it. Of course, just stick more on if you want more of an angle. And then I have used this repurposed RunCam Velcro strap, and that goes underneath the FPV Cam plate. There's a little slot for some Velcro, which is really nice, so that is in really securely. And then we also have this Velcro strap here as well to keep the battery, and this is one of the RotorGeeks battery straps that you get when you buy a load of props off them. I really like those. And lastly, there is the props. So how do you know which way around the props go? Well, first of all, we need to talk about the motors, because the motors have directional locking nuts. So the black ones are for the clockwise motors, and the red ones are for the counterclockwise motors. They will not go on the incorrect motor. So for the props, it's pretty straightforward. The way that I remember it is a propeller has sort of like a curved edge. Can you see it there? And that, from the front of the quadcopter, should always point inwards, and the same with the other side. So you see, curved edge, both of them are curving into each other. And it's the same for the other end, except you flip it around, and just think of it like this is now the front of the quadcopter, and again we've got a curved edge and a curved edge, and those both move into each other. So they move that way, and then same that side that way. And I used a socket set there to tighten them up. Now these are locking nuts, so you can tighten them up pretty tight. They usually turn quite easily, and then they lock when they are at the bottom of the propeller, so you can't really over tighten them, which is nice. So I'm just going to set up the on-screen display, and you will notice that with the Foxeer camera you are given this cable which detaches down here, which is just fantastic, and then this plugs into this little remote here. So before I explain the controls on the remote, I will just show you the on-screen display and what you get. So of course you need to plug a battery in. I've got a DVR connected. So this middle button here goes into the menu if you long press it. But before I do that, just take a look at the on-screen display there. You can see I can put my name. I've got NDRC, and I've got a 4-cell battery connected. It guesses that automatically from the voltage. And then we have a timer as well. This on-screen display is fantastic. You can move any of these around the screen that you want. You can turn any of them on or off, and you can actually have an extra item on the screen as well, like an extra name if you want. So if you long press the middle button, that will take you into all of the HS1177 usual settings, and I generally don't change much. If you go into special, you see you can have a cam title, which I've got selected as on, however it's blank at the moment, and you can change the position of that. So you can have something else on the screen as well if you like, but there's no need. I just have everything that I need here already. So I'm going to go over to end and cancel that, and I don't use any of this at all. So the thing that I'm mainly interested in is the on-screen display settings, so I'm going to press return and then exit. So to get into that menu, you long press the top button on the remote, so I'm going to do that. And there you go, you can see that we've got the name at the top. Now, these buttons on the remote allow you to go ahead and change the different letters. You see I'm moving up and down the letters, left and right, up and down, really nice. And then middle is to select, and your blank is up here as well, so I've changed it to NDRC. And then you've got the option to have the name on or off, the time on and off, and the power on or off, which is great. You can just customize it. So how do you get them to the place on the screen that you want? Well, I'm going to exit out of there, and then if you long press the left button, you see it will start flashing. Then you can use the up and down on the remote to place it where you like. I like it there anyway, so I'm just going to leave it there and just press it in again until it stops flashing. And then you can use the right one to move the time, so press that down again and you can move the time to wherever you like. And then the bottom one changes the battery voltage. Now, one thing that you don't get with this on-screen display, and I really don't care about it, is you don't get a current sensor, but that's fine. You've got a timer there, and you've got the battery voltage. That's all you need. You can also adjust the voltage if it's reading wrong as well. However, it seems to be reading correctly for me, so you can adjust the scale of it here as well. See, using the up and down, but like I say, it's reading correctly for me out of the box. So that is the OSD. It's really good. I think it's fantastic on-screen display, and you can just disconnect this remote and connect it whenever you please. Really nice. Okay, so now it's time to do the maiden flight. Now, I always do the maiden flight line of sight first of all, for safety and to just see that everything is behaving as it should. I always load it up with everything. So we've got the camera, and I am going to turn the transmitter on first, and then plug in the quad, and we have a bind. And then usually what I do is I stand quite far back because if I've got something wrong, the thing could flip over or go out of control. So I'm going to have my finger on the arm switch there, but it looks like it's idling nicely. I also keep it in angle mode, and what I'm looking for is just all the controls working properly, and then secondly I'm going to look for any tuning problems, jitters and stuff like that. So let's have a go of it. Well, it's looking good so far. Seen a couple of little jitters, nothing terrible. So I think the P value is too high, and also the I slightly. So far so good though. Seems pretty nice, sounding smooth. Loads of power. So looks like this is good. Wow. So much power. Okay, I'm not completely happy with the tune. So I am going to bring it in for a landing and change the PID slightly. So back to Betaflight, and the first thing I'm going to do is decrease the I on the pitch down to 45, and I'm also going to decrease the P on the roll and the pitch as well, because I'm getting micro jitters. They're not too bad, but it's a sign that the P is slightly too high, and also the I. So let's go and do some FPV. So the first thing that I noticed from the video is that I'm getting vibrations on the screen at very low RPM, and that is these King Kong props. They aren't very good. I cannot recommend them. They're okay on high RPM, but as soon as you lower the throttle, there's a vibration. So I will probably recommend the Dell props. I'm going to stick my HQ props on this after this flight. Now, I also mentioned that there's probably going to be some noise on the picture, and there is. So it's not unflyable, but I find it quite uncomfortable. So I'm going to add a regulator in there to get rid of the noise, and I'll show you how to do that. So remember when I said that the XT60 connector wasn't very good on the Martian frame? Well, I'm just flying about trying to get a good tune. And as I say, the tune's really good, but the XT60 connector is really weak. And I was flying around, and then watch what happens. The battery comes unplugged in the air, and amazingly, the quadcopter lands flat and nothing is broken. But I think it's time to get back to the bench. So I have taken everything apart again, and I'm going to desolder the positive wire of the VTX from the power distribution board, and also desolder the negative wire. I'm then going to tin up the voltage out pad and ground pad of the regulator. I've already added the voltage in wires on the other side, you can see there. So now I'm soldering in the positive wire of the VTX to the output of the regulator, and also the ground cable. Now, I thought I could get away with just soldering the VTX to the output of the regulator. However, I flew the quadcopter in this configuration and there was still noise on the picture. So I'm adding the heat shrink here. However, in a moment I'm going to cut some of that away and desolder the camera from the power distribution board as well, and solder that up to this regulator. So this is the regulator being soldered to the power distribution board, so that's the voltage in on the regulator, and this is the negative as well. And now I'm cutting out a section there, and I'm going to add in the positive and negative of the camera. So I'm desoldering the negative of the camera from the power distribution board. I'm very gingerly desoldering the positive wire, leaving the V sensor soldered in. So that's the positive wire going into the other side of the regulator, and the negative, making sure I'm not disturbing the other wires that are in there. So next I have desoldered the XT60 connector because it was rubbish and it just bent out of shape. So that is the solder sucker there, and I'm taking this better XT60, which is a nicer fit, and I have added the opposite mating to it so that it doesn't come apart whilst I'm soldering it, and this one fits much more flush against the power distribution board than the other one did. The other one just completely bent to one side and it wasn't very good at all. So it looks a little bit messy, but I am filling these cups up with solder here, and I'm not going to have a problem with the XT60 connector again, I think. So I'm just adding loads of solder until it's full to the top and it's nice and neat. So this is the DVR footage with both the FPV camera and the VTX running through that 12 volt step up, step down regulator, and I'm thrilled to say the picture is as good as it's ever going to be. You can also hear the onboard mic as well. I'm never a fan of onboard audio, but this is the quality that you get if you are interested. So there you go, that is my video on how to build a cheap quadcopter. I hope you enjoyed this video. I'm going to leave you with some flight footage, but as always, thanks so much for watching. Please continue to subscribe. Cheers.
No, there ain't no stopping us. Fly without boarding pass. Couldn't catch me, I be moving fast. Call me a shooting star.